Myself Swapnil sir, and today I am here one of the previous question from NDA and NA 2021 question paper. I already uploaded plenty of the questions from all years of the previous year questions, and still I am uploading every day. You all need to be familiar with the previous year question, so it is very much easier to attempt the next attempt for NDA. So it's my request to you all have to see my previous year videos from the my channel. I already uploaded plenty of the videos there. It is very much useful for understanding of mathematical concepts. So in my today's video, I'm going to explain to you all one of the previous year question from NDA and NA question paper 2021. First of all, we're going to understand the question and then we'll go for the detailed understanding of solution. Now let's get started our today's question. How given, suppose 20 distinct points are placed randomly on circle. That means we have circle and we have to place 20 distinct point on a circle. Okay, that means there are infinitely many points are there in circle, which boundary of circle. But in our question we have given only we have to place 20 distinct point. Okay, and using this data we have given two statement. And first statement it says that the number of a straight line that can be drawn by joining any two of these points is a 380. Okay, and second statement it says that the number of triangles that can be drawn by joining any three of these points is 1140. Okay, so we have to figure it out whether statement 1 is correct or statement second is correct, or both of these are false or both of these are true. Okay, so we have to select correct statement. So options are given only first true, second true, third option given first and second both true, and fourth option it is given neither first nor second are true. Okay, now let's get started our today's solution. We'll see detailed understanding of our solution. We have given 20 distinct points are placed randomly on circle. So we have circle and we have to place 20 distinct points randomly everywhere on circle. Okay, on the boundary of circle. And the first option says that the number of straight lines. Okay, so what is the first statement? It is here the number of straight line, so which can be drawn by that circle. Okay, the number of straight line that can be drawn by joining, okay, so which drawn joining any two of these points is a 380. Okay, that means we have circle over here. Let me explain. So here we have circle. Okay, and we have to plot 20 points. Okay, 20 distinct points. That means they cannot coincide, they are at a distinct place, 1 2 3. Okay, and so on. There are 20 distinct points. Okay, on circle. So we have placed 20 distinct point on a circle. Okay, and we have to draw the straight line that can be joined any 2 points. Okay, now consider, if I consider this point and this point. Okay, so if I'm going to join this point and this point over here. Okay, so that can be joining any 2 points is a 380. Okay, so we get the 380 straight line that we can join this distinct point. Okay, how many straight line? We get the 380 straight line. So we have to find out the solution by using probability and probability distribution. Okay, so we have to use a combination, a permutation, such a concept over here for finding the solution. Okay, now let us see here the number of straight line we have here, total distinct point. Okay, so we have completely total 20 distinct point. Okay, and within that 20 distinct point we have to join only 2 points. We don't have to worry about 18 points. Forget about the 18 points now. So first of all we have to join 2 points within the 20 points. Okay, so for that we have to choose 2 points, and when we have to choose any 2 point or a selection is there, then we use a combination. We use a combination from your permutation combination chapter. Okay, so probability chapter, we use a combination. When it is the part of a selection, okay, then we use the combinations, and when it is the part of arrangement, then we use the permutation. Okay, so now we have to apply combination. Okay, and whenever we have to apply combination, we know that we use a NCR result. What is the NCR? It says that n factorial upon r factorial into n minus r factorial. Okay, this is the standard result for finding combination of our distribution. Okay, so we have selection, some particular selection between 20 distinct points. So that's why I'm using here combination part. Okay, so here how many total distinct point we have here? 20 distinct point. Okay, so n means number of all elements which is in our sample space. Okay, so n, it is here total number of a distinct point, okay, which is 20, and within that how many of these points we have to select. Okay, so that denoted as r. Okay, so that denoted as r. And how many we have to select the point? The number of straight line that can be drawn by joining any 2 points. Okay, so how many points we have to select? Only 2 points. Okay, so I got the total number of 20 points, and within that I have to select 2 points. Okay, and we have to find out after joining these 2 points, can we get the 380 number of straight lines there? Okay, now let us find out. Okay, let us find out, can we get 380 or some other? Okay, so we have to find out ENCR, that means 20C2. Okay, when it is a part of combination, part of selection, then apply combination. Okay, so 20C2. Okay, so what is the 20C2? Which comes as a 20 factorial upon n factorial means 20 factorial, 2 factorial, r factorial means 2 factorial, which is a 2 factorial. Okay, 2 factorial, and further 20 minus 2, which is a 20 minus 2 factorial. Okay, so which is 18 factorial. Okay, 18 factorial into 2 factorial. So what we will get here? We can write 20 as 18 factorial multiplied by 19 multiplied by 20. Okay, so how I have written? So 20 factorial, how can we write? 20 factorial can be written as 20 multiplied by 19 multiplied by 18 multiplied by till 1. Okay, we take multiplication 1 to 20, which is a 20 factorial. Okay, so can I write 20 multiplied by 19 and multiplication 1 to 18 as a 18 factorial? Okay, so I just expanded this term into the 18 factorial. Why I expanded? Let us see in our next step. So 18 factorial, it is here 19 into 20. So total divided by denominator, what do we have? 2 factorial into 20 minus 2, which is 18 factorial. Okay, so 20 minus 2, which is 18 factorial, 2 factorial as it is. Now see why I taken this 18 factorial at numerator, because we can cancel this one with this one. Okay, so if these two factorial get cancelled, then we'll add on some easy steps, because it is quite difficult to find out the multiplication up to 20 factorial. Okay, so always try to cancel the term. So 18 factorial will get cancelled. 2 factorial means 1 into 2 means it remain only 2. So 2 ones are 2, 2 tens are 20. Okay, so we left here with the value of 19 multiplied by 10, which gives us 190 answer. Okay, so by using our 20 distinct point, number of a straight line that can be drawn by joining any two points in our circle, we get the total 390, but it is given 380. So how it is possible? So discard the first option. So our statement first, which is completely wrong. Okay, it is a very much easier question, nothing is difficult. Just whenever you have selection, or you have to pick some points between other point, okay, between more set of points, so that time always use combination. And if you wanted to arrange a point, okay, now instead of this question, if you have given like arrange 20 point on circle, so arrangement is there, so we have to arrange 21 here, 1 here. So if arrangement is there, then apply permutation. And permutation, what it is, it says that we have to apply NPR formula. So n factorial upon n minus r factorial. Okay, so we have to apply the NPR formula. So but here we have only the selection, that's why I used here combination and NCR formula. Okay, so I hope you all have understood my first part of statement. And now let us move for another statement. Now another statement we have here, the number of a triangle that can be drawn by joining any of these 3 points, which is 1114. Okay, so we have a circle which is placed at 20 distinct point at everywhere. Okay, so we have a number of 20 distinct point placed everywhere. Okay, so what we have to do, we have to draw the triangle. Okay, so for drawing triangle, we need to draw 3 straight line. Okay, so for triangle, so here if I consider this one point, this one is another point, and this one is third point. Okay, and for drawing the triangle, which all points are there in a circle, so we'll get the number of straight line, which is a 3. Okay, so see here, we can have I drew it. Okay, so I have to plot the triangle in our circle in a such a way that these three distinct points get joined. Okay, so these three distinct point has to be a joined together. So we have total number of 20 points. So within this, how many triangles are possible that can be drawn by joining any three of these points, which is 1114. Okay, so we have to find out how many points we can select here. It is again selection, it is coming like a previous one. Okay, so in my previous we also did selection of 2 points. Now here a selection of 3 points for drawing the triangles. Okay, and they have given total number of triangle we can draw here as 1140. Okay, now let's find out. We have total number of 20 points. Okay, again we have selection here. Okay, be careful about combination and permutation. So we have selection of 3 points here. So instead of 3 points, they have given triangle, and obviously triangle is having 3 points. So otherwise without 3 points we cannot draw the triangle. Okay, so I drew it over here. Okay, so for drawing the triangle we need at least 3 points. Okay, at least means exactly 3 points, then we can draw the triangle at their vertices. Okay, so these are the vertices of a triangle. So 3 point I join here. Now what do we have to do? We have to select the 3 points. Okay, so again we have to apply the result for NCR. Okay, again we have to apply the result for NCR. Why NCR? Because there is a selection, okay, of 3 points between of the 20 points. Okay, so how many EN we have here? Number of points 20 points. Okay, number of selected points are, which is here 3. Okay, now in this part we have to find out NCR means 20C3. In our part first of option we found the value for 20C2 because 2 points are there. Okay, so 20C3. Okay, so we want the value for 20C3. so what is the value for NCR? You already seen. Okay, n factorial upon r factorial into n minus r factorial. Okay, so which is a 20 factorial upon r factorial, which is a 3 factorial, is into 20 minus 3 factorial. Okay, now 20 minus 3 factorial, it is coming 17 factorial. Okay, so 17 factorial, if it is a part of denominator, try to take that 17 factorial at numerator too. Okay, so 20 factorial can be written as 20 multiplied by 19 multiplied by 18 multiplied by 17 multiplied by 16 multiplied by so on. So we can write it is the 17 factorial. If you how difficult to understand these things, how to find factorial and how to apply these into permutation combination, you may check it into my playlist. I already uploaded similar videos on my channel. Okay, so here I written as 20 factorial this way. So 3 factorial as it is, 20 minus 3, which is a 17 factorial. Okay, so similar term numerator, similar term denominator, cancel it. Okay, so 3 1 the 3 factorial means 3 2 the 6, 3 into 2 into 1, that means 3 2 the 6. Direct, do not go for division. So 6 3 2 the 6, and 6 1 the 6, 6 3 the 18. Okay, so we'll get the 20 multiplied by 19 multiplied by 3. Okay, so 20 multiplied by 3, which is a 600, and a 600 multiplied by 20 multiplied by 3, which is a 60, and 60 multiplied by 19 will get the 1140. Okay, this is the required answer. Okay, so the number of triangle that can be drawn by joining any three of these points will get the 1114. Okay, so we have plotted these 3 points on triangle, and then I got the answer, which is 1114. Okay, so it's a very much easy solution. I hope you all have understood, because nothing is difficult over here. So even after, if you found anything difficult, let me know in comment section. I will come up with some other videos. I hope everything it is easier here. Okay, so thank you everyone. Thank you for my today's lecture.